Morning rap fans, I've had a request from Eleanor who wishes to go over the solution of MA1500 exercise 3.1 question 4. And the question states that we have two random events, A and B, and that the probability of A is a half and that the probability of B is 3/4. The first part of the question asks us to show that the probability of the event A intersect B lies between these two limits. Okay, let's first look at the upper bound. We need to show that the probability of A intersection B can be bigger than a half. So what do we know? Well, we know that A intersect B is a subset of A, and so by the monotonicity of probability, the probability of A intersect B can't be greater than the probability of A. Likewise, A intersect B is a subset of B, so the probability of A intersect B can't be bigger than the probability of B. Consequently, the probability of A intersect B can't be bigger than the minimum of the probability of A and the probability of B. So if we look here, we see that the probability of A is a half, the probability of B is 3/4, so the probability of A intersect B can't be bigger than the smallest of these, which is the probability of A, which is a half. Okay, so let's turn our attention now to the lower bound. We need to show that the probability of A intersect B can't be smaller than a quarter. Okay, so the way to see this is to start with the addition formula, which states that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And of course the probability of any event, including the event A union B, can't be greater than 1. Now if we arrange this inequality here, we find that the probability of A intersect B is greater than or equal to the probability of A plus the probability of B minus 1. So substituting in the values for the probability of A and the probability of B, we see that the probability of A intersect B is greater than or equal to, where are we, a half plus 3/4 minus 1, which is a quarter. Or in other words, we prove the lower bound. And combining that with the upper bound, we prove part A. Okay, so part B of question 4 is to show that the probability, not of A intersect B, but this time that the probability of A union B satisfies the bounds shown here. So if we first take the lower bound, the key points here are that the set A is contained in A union B. So again, using monotonicity, we see that the probability of A is less than or equal to the probability of A union B. And likewise, the set B is a subset of A union B, so the probability of B is less than or equal to the probability of A union B. And what this means is that the probability of A union B has to be bigger than the maximum of the probability of A and the probability of B. Okay, so the probability of A is a half, the probability of B is 3/4, so this shows that the probability of A union B can't be smaller than 3/4. So finally, if we turn our attention to this upper bound on the probability of A union B, well, this is trivially true because the probability of any event can't be greater than 1, and of course A union B is just an event. Perhaps to adopt a more general approach to this question, let's start again with the addition formula. So this is that the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. So if you consider this right-hand side, we're subtracting something positive, which has the overall effect of reducing the right-hand side. So consequently, the probability of A union B can be greater than the probability of A plus the probability of B. And as previously mentioned, neither can it be greater than 1. So we get the general form that the probability of A union B can't be greater than the maximum of 1 and the sum of the individual probabilities. So in this case, the probability of A is a half, the probability of B is 3/4, so add them together and you get 1 1/4. So in this case, we have the probability of A union B is less than or equal to 1. In other situations, of course, it may well be that this number here is less than 1, in which case we would just simply have the upper bound that the probability of A union B is less than or equal to the sum of the individual probabilities. So that concludes my solution to exercise 3.1, question 4. Thank you and good night.